Hello, this is Peter from Educomondo and a warm welcome to our third STEAM lesson, Teacher Edition, called The Twinkling Star. This series of lessons is for teachers who are absolute beginners in the field of STEAM and programming. STEAM brings science, technology, engineering, arts and math together in fun projects, and your students will learn while they are experimenting. Today we are going to continue with what we learned in Lesson 2, the eye of the dino. But instead of making the LED go on and off, we will make it fade in and fade out. To achieve this, we will cover the following new topics. Learn the analog write command. Understand the basics of pulse width modulation. Introduce the for loop. Practice our breadboard building skills. And solve errors and work as a team to find solutions. Here is a project board that by now will look very familiar to you. If it doesn't, go to our previous lessons where we explain how the microcontroller and the breadboard work. For this lesson we are using the original Arduino Uno microcontroller, simply to show you that there are many alternatives available and that they all work pretty much the same way, because the Arduino is an open source hardware platform. From the STEAM Starter Kit, select the following components and hand them out to your students. The project board with a USB cable, a blue LED, a resistor of 220 ohms, 2 jumper cables, a red and a black one to clearly distinguish between the plus and the minus side, and the most important, the star figurine. If you have a soldering mat like the blue one that I am using, put the components into these compartments. It will help your students to work in an orderly manner. Now that your class is settled, let's review with them the circuit diagram that we will build. We start from our power source with the plus and the minus. From the plus, we go to the resistor of 220 ohms. From the resistor, we go to the plus leg of the light emitting diode. This is the long leg of the LED, and from the short leg of the LED, we continue to the minus or ground of our circuit. Now it's time for your students to build the circuit on the project board. First we put the LED in place. Then we attach the resistor to the long positive leg of the LED. Be careful this time. You cannot just put the red wire in any of the digital pins. You need to put it in one of the pins with the tilde or wave symbol. The black wire goes into one of the ground pins, and last but not least, we push our star figurine over the blue LED. In the previous lesson we have seen that the digital pins are either on or off, providing 5 volts or 0 volts. We use the command digital write. But there is no way to get 2 volts or 3 volts. So how can we dim an LED digitally? This is where pulse width modulation comes in, abbreviated PWM. This is a way to simulate a lower voltage on the digital pins. But this only works on the pins that have that tilde. On the microcontroller, these are pins 3, 5, 6, 9, 10, and 11. The output of the digital pin will look something like this. A straight line on 5 volts or a straight line on 0 volt. Any value in between isn't possible. However, we can quickly switch the on and off state of the pin, and we can adjust the time that the signal is on or off. In other words, we can modulate between 0 and 5 and its duration. When we look at this over a period of time, and the voltage is half of the time on and half of the time off, the LED will be on for half a second and will be off for the other half second. If we increase the time that the signal is on to 25% and off to 75%, then the LED will be seen as glowing a quarter of its brightness. And when it's on for 80% and off for 20%, then the LED will light up at 80% of its capacity. Later on in this lesson, we will be able to show this on the oscilloscope. Now is a good moment to let your students connect their project board to the computers and launch the Arduino programming environment. We start by typing 2 slashes and giving our file a name. Lesson 3, Twinkling Star. Then we create a space where we will put all of our variables. We don't want to declare variables throughout the program. We need to create a pin variable, and since we linked the blue LED to pin 5, we can write int blue pin equals 5. Remind your students to always close your code with a semicolon. At this stage, we don't know of other variables that we might use in the program, so we can go to the void setter part and set our blue pin as an output pin. Pin mode, in between brackets, blue pin, output. Don't forget that output is written in capital letters. In the void loop section of the program, we will introduce 2 new commands, the for loop and the analog write. Follow me while I am typing the following command lines. Let's break this code down in easy to understand parts. The for command is followed by, in between right brackets, 3 arguments. We set the value of our newly introduced variable, called value, to 0, and for as long as that variable is smaller than 255, the microcontroller will add 1 to the variable value. And for as long this is ongoing, it will execute the lines in between the curly brackets. It will write that value to the blue pin using the command analog write. With each run of adding a 1 to the counter, there is a delay variable dt to slow the process down. The number 0 corresponds with 0 volt and the number 255 corresponds with 5 volts. How we arrive at the number 255 was the subject of our lesson on binary systems. Suggest your students to revisit that lesson if they don't remember. Once we reach the maximum of 255, this loop of adding 1 to the previous value will stop and the LED will be at its brightest level. That is why we need to add another for loop in order to bring the brightness down again. We need to program exactly the opposite of the previous for loop. Follow me again while I am typing. We start at the value 255, and for as long as we have not reached 0, we subtract 1 in each cycle of the program till it reaches 0, and then it goes back to the previous for command and will start to increase till 255, and then again, you guessed it, it goes down again. Before we run the program, we should not forget to declare our delay variable dt and the value variable. int dt equals 10. We use a relative short period to create a nice glowing star effect. And int value, where we don't need to put a value because the value is calculated in the for loop. Let's upload our program and check whether it is working. Yes, we can clearly see the blue LED go on and go off. If you have an oscilloscope in your classroom, you can show your students in real time that the waveform looks exactly how we have drawn it on the whiteboard. You connect the positive probe to the positive leg of the resistor and the negative probe to the negative leg of the LED. This is a great visual demonstration of how the program is first increasing the time it provides 5 volt to the digital pin and afterwards decreases the time of 5 volt while increasing the time it doesn't send any voltage to the pin. Both the large and the small oscilloscope do a good job in showing your students this mechanism. Let's spend some time looking at the waveform expanding and contracting. Today's lesson might have been a bit complex, so check with your students that they have fully understood this principle. What if with some students it doesn't work? Tell them not to panic. Ask your students to do some logical fault finding. Did they end all commands with a semicolon? Did they spell all commands correctly? Arduino has some strange ways of writing commands with upper and lower cases in the word. Did they not delete any of the accolades throughout the program? Are all wires and legs in the right pins? Did they declare the right pin number as a variable? Are all connections on the breadboard firm? Is the LED not broken? Understanding why an error occurs is an important part of their learning experience. It trains your students' ability to look critically at their own work and solve complex problems. This concludes our third project, the twinkling star. Repeat to your class that I have learned the following. to use the analog write command, why a pulse width modulation simulates a lower voltage on digital pins. They learn to code with the for command and practice their skills on the breadboard. And maybe the most important, they conducted some error and solution finding as a team. Don't forget to motivate them by telling them they did a great job. Before you end the class, wouldn't it be a great idea to give your students an assignment involving stars? Here are a couple of questions that they can research and later present their findings in front of the class. What is a star? What is the difference between a star and a planet? What is the nearest star that we can see? What is a solar system? Can you name 5 stars and tell where they are in the galaxy? And how many stars are there in the universe? Have fun with the assignment. I hope you enjoyed this lesson, and I look really forward to getting to the next one. An important lesson on traffic safety, because we are going to program a traffic light. Bye bye.